Other topic that we need to look at is how we have been writing our programs. If this is a hole that we want to circular interpolate, we already learned the code to do that would be to position our tool in the center of the hole. So we'll say something like G00 based on my example here, X4, Y3. And then we'll do a G01, feed a Z down to some depth. And then we'll move over to here. And we're going to say if this is a 2-inch radius, this dimension would be a move to X 6 inches. And we're still at Y 3.0, so I'll leave that in there. So we've gone and made one positioning move to the center. Now we moved over to the edge. And now we'll cut our circle. And we'll say G02. Go back to the same place we just were, X 6.0, Y 3.0. And this is our temporary datum, so where is the center in relation to that? It's at I minus 2 and J0. Brings us back, after cutting a clockwise full circle, puts us back to where we were. And then we could do, let's say, a G01 to go back to the middle at X 4.0. All right? That we've done, we understand that. But what we haven't done is to think about now that when we do end milling, our cutter has a radius, right? There is a radius associated. So if we use an end mill, and this is a 1-inch diameter end mill, and that's what we used on this job, what's actually happening? We're bringing in a 1-inch diameter tool into the center of the part, because remember, we're always driving the center line of the spindle. And then we have a 1-inch diameter part that goes there, and then it makes a full circle around, and then comes back to there. What's actually happening here? It's only removing material on each side of the cutter. And the cutter is going to the finished size of our hole. So if this hole was meant to be 2 inches or a 4-inch diameter when it's finished, right, because 2-inch radius, if the hole is meant to be 4 inches in diameter, and we went and took a 1-inch diameter end mill and did the program the way we learned, what you're going to get is a finished part that looks like this, that's going to be 4 inches plus your cutter diameter oversized. So what's going to happen is when we have this program, because it's a cutter that has a diameter, it is going to be 1 inch larger than the drawing calls for. Because we have not, repeat, we have not made allowance for the diameter of the cutter. Let me take and show you another example where this will be relevant. Maybe it's not as clear with the hole, but if we're milling a profile, we just come right over here, and if this is my coordinate system, and I want a profile that we mill that is 2 inches high, 4 inches long, and it's a simple square. This is the finished size that we want. 4 by 2. And what's going to happen when I take a full-size 1-inch diameter end mill and say we're going G01, X0, Y0, and then we go up to Y 2.0, and then we go over to X 4.0, and then we go back to Y0, and then we go back to x0. So here's our path. Here's representative of our cutter diameter. And here is the edge of our cutter. It's removed all this extra material. And we will have a part that is only 1 inch by 3 inches, because the back and side of the cutter have removed all of this material. So how do you then get to a finished size? There's 2 ways we could do it. One way is to adjust all of our coordinates by the radius of our cutter. So in this simple example, to get a 2 by 4 inch square, with a 1 inch diameter cutter, means we have to adjust all of our dimensions by a 1/2 inch. So that our cutter path now, if we picture the logical extension of this part, our cutter needs to sit exactly 1/2 inch, or its radius, away from the finished dimension. It must go past this dimension by 1/2 inch. So our cutter path for a 1 inch diameter cutter will be represented by this green line, and will then leave us with a finished part that is 2 inches by 4 inches. So we need to adjust our program, and you can manually do this. Again, if you do this with a 1 inch diameter cutter, our first move, instead of becoming x0, y0, which would be there, our first move would be g01, x minus a 1/2 inch. So that's half the diameter of the cutter on the minus side of our datum, which is right here in my example. Y minus 0.5. Then our next move becomes y 2.5. So that then takes the center of this cutter and puts it 0.5 past our finished, its radius again. And then this becomes x 4.5. So then our cutter comes out to here and follows the green path. And then we go to y minus 0.5 again to bring it down here, and then back over to x minus 0.5. This is adjusting for your diameter of your cutter manually. That will work just fine. What's the problem that you might see with doing things this way? How about to cut a simple part? This program is only good for one and only one cutter diameter size. It's a 1 inch diameter cutter that this program was written for. Which, if the cutter is brand new and you take it out of the box, it will probably be perfectly 1 inch in diameter. But as you use that end mill, it's still able to make a nice cut, but it will start wearing down. So instead of a 1 inch diameter end mill when it was new, you might end up with a end mill that is now 0.99, which would bring and make a part that's out of size tolerance by exactly the amount that it has shrunk. So, manually adjusting programs hurts you 2 ways. It locks that program and makes it only useful for one size cutter. And it locks you in because doing it this way, your cutter has to be full size. It can't be worn. It has to be brand new. Otherwise your program's no good anymore. You don't want to rewrite the program for something as simple as small amounts of wear on your cutter. So how do you compensate for that? It's actually very easy. The answer is you continue to program and think about programming like we have been. But now, what we're going to do, introduce you to a couple of new commands. There's a command called G41 and a command called G42 that are used in conjunction with X and Y movement and the letter D, which kicks in a diameter register value that's stored in a register just like the tool length is. So to kick in and use your cutter comp, G41 is comp to the left, G42 is compensate to the right. And the way you think about this is put yourself on top of the cutter, looking at your cutter path. Do you want to shift to the right? So if you're looking down on this particular cutter path that we have written, do you want to offset to the right or to the left? If you want to offset to the left, you'll use G41. So for this example here, that cuts a 2 by 3 inch or 2 by 4 inch square, we would use cutter comp exactly like this. Prior to the G00, instead of going to X0, Y0 right away, what we're going to do is we're going to say G00, X, and then come out here like -1 inch and -1 inch. And then what we're going to do is we're now going to say G01, and then we'll put in the G41 here in this same line and say X0, Y0, D1 if it's tool number 1. And out on the machine, in register number 1, we type in the diameter or the radius of the cutter. And then just continue to program exactly the same way. And then when we've completed our cut, what we do is we say G40 and go back to that sort of further out start point. X minus 1, Y minus 1. And we're finished. That's all you need to do, is kick in cutter comp. To do it on a circle, there's a couple of rules there, and let's review those. If I have a circle, here's our datum, and let's say this is at 2 inches over in X and 2 inches down in Y, and let's say that our circle is a 2-inch radius. What we're going to do is we're going to move to the center of the circle. We're going to say G00, X2, Y2. We're going to say G43, bring our Z down to whatever depth we want to use, H1. So now we're sitting here. Now, cutter comp in a circle, you must always begin cutter comp with a straight line move, and you must cancel cutter comp with a straight line move. We cannot cancel cutter comp in the middle or as the last part of a circular move. So now that we're sitting in the middle, And we want to take a path with our cutter that compensates to the inside and moves around clockwise. What we're going to do is we're going to say G01, G41, G42, I'm sorry, because if we're going this way, we're saying offset or compensate our cutter to the right of the material because this is a hole we're making. So G42, and we're going to say X, so if this was X 2 inches and this is a 2-inch radius, X 4.0, Y 0, don't forget your D and then your tool number or your register number. Generally we say if it's H1, it's going to be D1 for T1. Okay? Then you do your cutting. So we're going to say G02, go back to the same point we started, X4, Y0, I minus 2, J0. And then we're going to do a G01, G40, because we have to cancel comp on a linear move back to the center of the circle. G01, G40, X 2.0, Y 2.0. And you're done. So you have now simply modified any programs. You still think about it in terms of 0 diameter cutter, but then kick in cutter compensation either left or right.